I'm happy to share some information about the Qt Safe Renderer, which is, as you'll see, a way of rendering in a safe way. Come on. Okay, so here's the agenda for the quick, it's only a fairly quick talk, but here's the agenda. We'll take a quick look at functional safety and what we mean by functional safety. We'll take a look at soup, which is a bit too early for lunch, so we'll look a bit more at that later. We'll have a look at what we mean when I'm talking about safe QML, and look at safe QML, controlling it from your safe C++. Finally, I'm going to cover the new safe animations, which is a new feature of Qt Safe Renderer 1.2 that's coming out fairly soon. So we'll take a look at how that runs. Okay, so functional safety, what do we mean? How do we make software that end users can rely on? This is what we really mean when we're talking about functional safety. And it's fairly simple, of course. When you're writing your code, you need to basically write it to a robust code standard. You'd have that code reviewed by knowledgeable people. And in many ways, that's kind of the same as any other peer-reviewed software. You write it to a good standard, you have it reviewed by people who know what they're talking about, and then you have it, yeah, you should be safe. So when we talk about functional safety, though, the coding standards we're talking about here are quite high. We're talking about things like the MISRA, which is the Motor Industry Software Reliability Association. That's a widely used coding standard. In fact, Qt Safe Renderer is written to this standard. JSF is probably the coolest one. It's the Joint Strike Fighter coding standard. We don't use that so much, don't see it so much. And we're also talking about the ASIL standards, ASIL A, B, C, and D, which is the automotive safety industry level. Now that's more of a category of standards. That's more of a way of designing software. So it's certified to a certain level in ASIL. The certifying bodies, there are a couple. TUV is the one which the Qt company is using, and they will certify that the code is written to the standard required. Exeter is another fairly big one. There's a couple of others as well. And these certified bodies themselves are accredited or certified by various other certification companies. So there's the UKAS, IAF, ILIC. These are kind of the high-level certifiers that certify that the people certifying your code are themselves certified to certify that certifiable code. Okay. So these are the standards which we have for safe software, which demonstrates that the system is safe and it's not a significant cause of risk to the end user. So the big question we asked a few years ago is, how well does Qt measure up to these functional safety standards? And the answer is it's not terribly good at meeting these functional safety standards. So Qt itself is what we call software of unknown provenance. So if you're familiar with this term, it's SOUP, Qt is soup. Of course, by that, Qt is well written and it works pretty much correctly all the time. So it's a reliable framework. And it's open source, so you can read all of it if you want to read all of it. Unfortunately, though, there is a lot of Qt. If you've actually read all of the Qt lines, you'll be aware that there's about 18 million lines of C++, something like 500,000 lines of QML. That's a lot of code to read through. So certifying all of that, it's not really practical. There's just too much, and it changes too quickly to keep it certified and up to date. And it's kind of true about Linux as well. If you're running a system using or certifying a system using embedded Linux, then there's a good chance that your Linux distribution can't easily be certified either, although there are some certified safety Linuxes available out there. So safe QML, it doesn't really matter how careful you are with writing your QML and how safe it is. It's not possible to create a certifiable QML for the Qt Quick Runtime because Qt Quick Runtime can't be certified. So that's a huge dependency on your safety critical code, which can't be resolved. And then the question is, what can you do? How can we write a safe user interface using QML Qt Quick? The Qt company has a safe renderer, of course, which, as you know, which allows you to run your QML in a safe way. So how does that work? And when would you need it? So you would need this when you need a system that's not going to fail, or would you need it for a system that's not going to fail? And in things like the automotive industry, if you have a modern instrument cluster written in QML, you would need that to be certified to a high level. Same goes with medical. If you're a medical professional, you need tools you can rely on. Interestingly, railways as well. And in the aviation and space industry, of course, that's necessary. And yeah, when we talk about safe, we're really talking about a certified as safe. So it's not just you think it's safe, it's other people think it's safe, and it's an acceptable risk management. So it's good enough to be considered safe to use. And creating that user interface with the right components, of course, will make it a lot easier for your certifying authority, TÜV or whoever, to verify that you have written that correctly and safely, and appropriate risk management is there. So the Qt Safe Renderer comes pre-certified. The code inside the Qt Safe Renderer is certified to a ASIL-B standard, so and various other standards. In fact, these ones, ASIL-D standard. We're certified for functional safety in various ways to the main standard, which is ISO 26262, and various others which support safety critical components. And if you're writing to that standard or lower, then you can use the Qt Safe Renderer, and that will get you a lot of the way there. So that's why. Let's look at how we do that. So Qt Safe Renderer, when we talk or offers these three main QML elements with which you can use to write your safe UI. To make things clear, they're called safe image, safe picture, and safe text. We also have a safe message element, although that's not a UI element, that's a Qobject. It has no visible appearance. It's just used for sending messages. And in this way, the Qt Quick or the Qt Safe Renderer QML is very similar to ordinary QML. In fact, you can embed these elements directly in your regular QML, should you so need to, and it will pick these up and put them in a safe UI. So you can interact with them like any other QML element if you so choose, and build your UI that way. And that means, of course, that the Safe Renderer elements work with Qt Design Studio, which is also, if you're using Qt Design Studio, that's pretty handy. So obviously, Qt Safe Image is just an image. It takes an image like a QML image, but it's a little bit safer. It has higher standards, which are checked during compile time to make sure everything's there. Safe Picture, if you're doing a lot of elements like telltales, this kind of element, takes a QPIC format, which we usually call a DAT file. And then you add the color overlay. So that's like the QGraphics framework color overlay on top of a simple image to create a telltale. We'll see some of that later. Safe text, of course, is just ordinary text, and that's checked and verified that it's safe and is not going to cause a problem. Safe message is perhaps not, it's an interesting component. This allows you to send a message from your ordinary QML into the Safe Renderer runtime from the QML. One of the problems you might find with that, though, is, of course, is the QML, the Qt Quick UI, is not itself safe, and it's sending a message to the Safe Renderer. The Safe Renderer would be reacting to a message that's coming from non-safe code, which is maybe not that useful. So all of these safe elements in the UI, though, are checked during compile time. So the tools which come with the Safe Renderer will check that each of these elements is correct and complete. The size information, how much screen space it takes up, is checked. Elements are inside the UI boundaries. Now that's important in safety concept. The elements can't move outside the UI and become invisible, because that would be not safe. You wouldn't be able to see them. Images must have sources. Images also need, or elements also need their object names set. If they're not, then that will trigger a warning, and that's important because they need to be identified or identifiable by the Safe UI runtime if you need to interact with them. But yeah, as a rule, there should be no surprises in your code. It needs to be predictable. It needs to be robust and safe. Okay. Much time? Yeah. Good. So yeah, you use the QML elements to create a safe layer, or you can use them to create a safe layer. So there's two approaches to using them. You can embed the elements directly in the UI, and then when the tools run, that will create a separate UI, or a separate set of code. In addition to that embedded in the ordinary UI, you have a separate set of files which can be used by the Safe UI. This will then run generally in a separate application, which sits on top of the main application. Now that needs to run in a separate application because the separate application can't, if the main application crashes, then running in a separate application will prevent your application from itself crashing. So it sits over the top of the main UI, and it gives these elements there. So it kind of would give you a seamless kind of look, which is useful. The Qt Safe Renderer tools, as I said, they create a series of safe files, which are then loaded by the separate application, giving you the two applications, the main application and the safe application, which run separately. In fact, you could say that the main application, application one, is optional. You don't, strictly speaking, from a safety perspective, you don't need the main application. It can just sit there with the safe application, and you'd have all the safe information you need. On the whole, the two are used together, but you don't have to use them together. And there's different approaches to safe rendering for different customers. So you can use whichever approach you prefer, whichever approach makes most sense to you. One thing to bear in mind, of course, is that the Qt Safe Renderer itself is a pre-certified runtime, but it doesn't in any way certify your code. You would still need your code to be certified before it gets released. Okay, so controlling your safe application, functionally safe UIs need to be functionally safe from the screen right down to the back end. So you can't have any non-safe systems coming between the safe UI and the back-end information. It needs to come purely through a functionally safe approach. So if you're sending information from the main application to the safe application, then this could actually cause a problem when it comes to certification because you can't rely on the main application. But ways around that, the Qt Safe Renderer API does also have a way to provide, or it does also provide a way to send signals from your safe application to the C++, or safe application C++ to the Safe Renderer itself, which we'll take a look at shortly. And that's sent by functionally safe channels so that your safe application will be writing in a safe way to the Safe Renderer. Okay. C++ API, we've had a look at the QML API. This is the C++ API itself. As you can see, it's fairly simple. There's a safe layout resource reader, which you would use to read your safe files. You have QSafe events. Of course, these are entirely scratched or written fresh for the Safe Renderer. And you also have a state manager. Now, I don't know why that's called state manager and not QState manager, but I'm sure there's a good reason. But basically, or principally, the way to interact is you have the state manager in your safe application, and then you send safe events via the state manager to the Safe Renderer. And that's kind of all there is to it. It's fairly simple. In Qt Safe Renderer 1.1, we have these here event IDs, visibility, position, the heartbeat. You can send the heartbeat from the main UI to the safe UI to tell when the main UI is working. We'll give some input into that. Various other things. You can change the layout, you can change the system state, and so on. One nice thing about the Qt Safe Renderer is when you compile it, it compiles entirely into a statically linkable library, which with the Safe Resource Compiler tool allows you to create everything into a single binary. So the application itself does not have any dependencies when it's running on the operating system because it's entirely linked statically, which is useful. Okay, so as promised, animations in the Qt Safe Renderer. Now, this sounds like it's really an amazing, cool, super way of doing things, and it is, but it's not so simple. It's more, or it's not so complex or so sophisticated as the Qt Quick UI. It's a fairly simple animation framework. So whereas previously we used to have property changes, which would just change in the Safe Renderer, now we provide a form of transitions between the different property changes. There's a few limits, but rather than try and look at it too much, it's probably better if we take a look at the code. That would give us a clearer idea rather than go through this slide. But basically, it's don't get too excited by the animations in the Qt Safe Renderer. It does look nice, and it does go at 64 frames per second, which is cool, but it's not going to replace your entire UI. It's to make the safely rendered UI look a bit nicer rather than create a whole UI written in Qt Safe Renderer. So basically, if you're familiar with regular QML and you're familiar with state framework and transitions between those states, this is what we use in the Safe Renderer. So in this case, we have, in this sample code, I have here a safe image, which of course is just an image. It's got the width, height, it's all hard-coded, and it's just given the simple name circle. when the application starts, it's set in the state hidden, and the state hidden has property changes of opacity set to 0. So opacity is 0, as it shows here. When we change that state from hidden to shown, then it changes the opacity property to 1, which triggers this transition here. So when we're hiding it, it's going to give a duration of 1 millisecond, so you wouldn't expect to see it. When we're showing it, we have a duration of 400 milliseconds, which you would expect to be fairly slow. It should fade in quite gently. And that is triggered, I think, somewhere in here. Yeah, maybe not here. So we see in here somewhere, we should see the safe manager itself. So state man, what we do when we set the gauge visibility is we have a series of safe events. So in this case, we're using safe event change states, and we're getting the ID number for these state changes. If you're interested in what we have these ID numbers here for, this is basically, rather than sending strings, we send a safe hash for each string, which if we bore down into it, you'll see we have a safe hash of the name and the string length. So everything is sent as a 32 or QN32 ID. And that's how the messaging from the C++ is sent. It's all simple state change events via the state manager. So as you can see, it's useful, but it's somewhat limited. It's not super dynamic. It's not going to give you a cute, quick UI, but it will give you something very safe and very reliable. And at 64 frames per second, it will probably look quite nice. So as we saw, you create a series of states for each of the animatable safe elements. We add property changes to those states. We define the transitions, and we add animations to the transitions. We then, from C++, send the state change event, which is the final one here. 1.2, Qt Safe Renderer 1.2 also adds the event set color. That's for the safe pictures. When you have a single colorized icon, you can now change the color of them too at runtime, which is a useful feature to have if you're theming. Okay, so a quick look at the QML source code. We had a look just there at the safe code. If we look in the actual gauge panel itself, we see we have here, or in this demo, we have a gauge panel. Probably good to show you the demo too. I'll do that in a second. So we have a gauge panel here. And we also have a safe code. And the safe code, in this case, I've composed everything in a single QML element. You don't need to do that. You can embed them directly in the QML if you like. But for this case, it was made more sense to do it this way. And this is the application I have here. If you were in our talk a couple of months ago, you'll recognize this application as a very simple gauge with a dynamic telltale system running in it. And as you can see, the dynamic telltale animates in and animates out. You might also see there's a slight change in color when I move the telltales, and that's the safe renderer working in the background. The color balance on the safe renderer in this demo is not quite perfect, but that's not an issue you necessarily go to production with. I think that's fairly easy to resolve. In this demo, I have all the gauges hooked up to this single control, and I have this big red crash button. And what happens when I press the crash button is the gauge panel is unloaded. The gauge panel itself is currently sending a heartbeat to the heartbeat signal to the safe renderer or the safe code. So when I crash this, the safe code will get the signal, or will stop getting the heartbeat signal, and we'll change the gauge visibility here. So that's happening in here. I wrote this a couple of months ago and can't, yeah, there's the heartbeat here. So the heartbeat is sent, and if the heartbeat is not received, then the application will close. So this will happen. And you can see here that the safe renderer has appeared in the background here. These are the images which are in the safe code. They're fairly simple background images. This is nothing, this is not going to win us any design awards, but you can see that the driver would still have the information required. Additionally, because the safe renderer knows that the animations are not running, it's not pausing in the same way as it was before. So there you can see, hopefully that gives you an idea of the safe renderer, what it does, where you'd use it. It's a fairly simple part of the Qt solution, but it does do, it does serve a purpose in getting your product to market safely and certifiably. Okay, so the animations, we have various different types of animations, number animation, scale. We have easing types, and we're able to animate on the X, the Y, opacity, width, height, and scale. So you can increase the size, move things around, and change the opacity. So you may notice here in this demo that this is supposed to fade in over 400 milliseconds, but it's not quite working yet. The reason for this is because this is a very early version of the Safe Renderer 1.2, and I think it's something that is working in the later versions. Okay, so that's our demo there. We've seen the sample code in the demo application here. Fairly straightforward. This demo application, by the way, would not get certified itself because the safe code itself is built around Qt, so it's not certifiable. Additionally, it's all run in a single application, something which you can't do with the regular Qt Safe Renderer. I did actually patch Qt Safe Renderer to allow that to happen. Okay, demo source code is available, or should be available, from these places here. I've also provided a simple tool which will allow you to create the DAT files read by the Safe Renderer for safe pictures from any image. It's a fairly straightforward little application. If you have any questions, please add them to the chat and we will answer them at the end of the talk. Okay, so thank you very much, and I'd urge you all to stay safe and render safely.
I hope you guys can hear me. So these are the top 5 questions that I have come across recently when I was interacting with people in virtual trade shows or in online forums. So without further ado, let me start with the first question. So this was the question I got asked about deploying applications on Windows. Now, there are multiple ways to do it, but there is one prominent way that you can leverage. Qt provides an executable, a tool called WinDeploy Qt. Now, this is typically designed to automate the process of creating the deployable folder, wherein you don't have to go and start picking the libraries and the shared binaries yourself. So you run this tool once, you will get all the necessary libraries that are consumed by the application. There would be few extra libraries as well that you can get rid of over the period once you know that there are certain features that you are not going to use. That way you can reduce the size of the final deployable folder. Now this WinDeploy Qt is located in the Qt folder inside the bin. And you need to set up a build environment before you using it. And there are 2 ways to do it. Within that same folder, there is a script called Qt Env2. You can run that script in the command prompt that you would open, or there are these predefined shortcuts which get created for you when you install Qt on Windows. I'll just include one simple screenshot of one of the applications. So there you would see the highlighted portions. In case of KML files and any assets that you want to include, those would get included on their own. About the Qt DLLs, it would pick, I mean, the Qt shared objects that you would use, it would pick the right ones for you. It won't pick the extra ones that you are not consuming. However, there is one catch. There are some plugins which are loaded during the runtime. So it's difficult for the WinDeploy Qt to determine what are those shared libraries. So in that case, what happens, it copies over the entire plugins folder. And then I will advise that you would have to go look into those plugins folders and see if there are certain features that you're not using, and you can remove those DLLs by hand. Unfortunately, there is no clean way to do that. And once you get through this, you would get the final deployable, and then you can use the Qt install framework or any other installable wizard to create the installable for your application. So that's about the WinDeploy Qt. Now, I also got a question asked about how do I switch between different versions of Qt? And there can be different scenarios here. Let's say there is a team who is working on different variants of a product, and each product uses a different Qt version for the legacy reasons. And if you are building some continuous integration system, you would want to pick the right version while building the application binary. There are other ways to do it. On Ubuntu, there is a tool that has been that has been developed since long. It's called Qt Chooser. Uh, there are a few command line options to it. You can list the versions to figure what are the default versions that are available for you to choose from. You can print the environment variables. And then if you are doing a command line builds, you can use the right tool. Let's say I want to invoke Qt Linguist or lupdate. I can do that by using this parameter. Now the question is, okay, that takes care about the ones that have been already installed. What about if I have to add few versions of my own? What if I have a variation of Qt 5.12, which is a local build that I have created, and it has some flags that I have enabled and disabled? So you can do that. There are two files that you can edit. One is the global system-wide file, which would be available to all the users who are using that system. And then there is something that is local file, wherein you can add your variant of Qt. There are only two lines that you have to worry about. One is help find the tools, the binary files, the Qt binary files. And the second line is about finding the Qt shared object. There is ample help available on how to work around or how to work with Qt Chooser. So I don't have to delve too much deeper into that. The third question I got asked was about programming. So as many of you are aware, you can expose certain Qt classes and Qt, not necessarily Qt, but Qt derived classes or Qt derived objects to the QML world using set context property and similar API. But then when you use Qobject as a base class for such user defined classes, there is a catch. There is some extra code that gets added, and typically you are not going to utilize that. So does it really affect? Not that much, but if you are really peculiar about not or watching about the application binary size, then you want to nitpick what exactly you want to derive from Qobject, and if there is any other alternative. So the requirement here is I don't want to derive from Qobject because there are these other signal slots and other mechanisms that are exposed by the QMate object that I don't want to leverage. So give me something so that I don't have to inherit. But I definitely want some reflection capabilities that are offered by Qt Mate Object system. So what are those? So I'll answer is QGadget. This is one of the macro that you can use. In the beginning of that class, the user defined the class that you would be exposing to the QML world. Three prominent items available from the bit object system are enum, property, and invocable. Your methods would be prefixed with this invocable. And what I've seen people typically use these for is if there are any low level system calls or system interaction that one wants to achieve, that's achieved using these Q invocable kind of methods. And since you are deriving from, you are inheriting from this Q gadget, you're not loading that bulk of code that comes with the Q object. And still, you are getting the advantage of exposing your methods and properties to the QML world. The only downside is it doesn't have signals and slots mechanism. Another question I got asked was, so we have this Qt Lite. I don't know how many of you have heard about this, but Qt Lite is a config tool that helps you downsize the Qt binaries. So what do I mean by that? Those who have seen the Qt4 world, Qt4 was pretty much monolithic, but there were some options that you would have to figure out looking through the code to minimize the footprint of the final Qt binaries that you want to build for your end product. With Qt5, we did further modularization, wherein you can skip the modules at the high level, reducing the final binary that you would be putting on the device. But then within the module, you have certain features you can disable. Let's take an example. I'm just going to use buttons in my application. There is no list view or no other rich UI element that I'm going to use. Can I disable the list view code? Yes, I can. But then the problem was I would again have to go and read through the code and figure out what are the different macros I have to enable in my .profile so as to minimize my Qt binary footprint. Now, I'm not talking about the application. I'm talking about the Qt libraries that I'm going to build myself to put it on my end device. Now, the problem with that was it was a bit time consuming and there were some interdependencies. If you remove certain piece, it might have an impact on another piece, and that you would come to know when you would actually build the Qt lib. And in some cases, when you would actually use that component. So this picking and choosing process was a bit time consuming. Between mid of Qt 5, we introduced this configuration tool, and the result of that, we call it as a Qt Lite. So that Qt config tool helps you visually pick and choose the dependencies. And the advantage there is, since we have developed that tool and we have made sure that we capture all the dependencies, you don't consume too much time in figuring out whether it will work for you or not. You would definitely have to spend some time figuring what exactly features you want to leverage. And this typically you do once you are out of the proof of concept phase. But then the downside with that was whatever Qt Lite would create, that was consumed at the Qt base level. But since you can tune on and off few things at the module level, it was a bit tough to use it in the Yocto builds. So what we have done is we have improvised the Qt Lite tool. So there are these few steps that you have to take now. You run the configure command on the Qt source tree. By that, you would get some build folder, which has certain buildable files, big files being created. Then you run the Qt configuration tool on it. You pick and choose what different features you want from the Qt libs, different components that you want. And then once you are ready, you would export those features for the boot to Qt. Now, in the earlier version of the Qt Lite tool, we used to create a single file, which would have all the configuration options. And that worked well when you are doing a non-Yocto build. But with the Yocto build, the structure is slightly different. The modules get built separately. So that's why we had to make some improvement to this Qt Lite tool. And now the Qt Lite tool would create those module specific files. And then when you want to modify your Yocto recipes, you can now pick and choose these module specific files. And I have listed the steps for that. We also have a blog around this, how to get this done. Now, this is another question I get asked often. So let me give you a background on this. When we created a Qt for device creation, we started supporting some standard eval boards. But then, as you know, when you are creating the production ready system, you don't typically use those eval boards. You would go to a design house and create a custom board for you. Now, with that said, that means that we have to make some changes in our offering. But then in the Qt for device creation, what we provided was a set of BSPs that you can use to get starting with your development. But there was a less support available when it came to customizing those BSPs for the custom hardware. But then what we had was, we have something called as QBSP. Whenever we used to support the hardware, we made the necessary packages available through this QBSP. Now, what is this QBSP? It's a combination of the tools chain, the target device image, and the Qt creator configurators. And how does this help an application developer's life? With the tool chain, you don't have to go and figure what compiler and linker to use. With the pre-created target device images, you don't have to figure what image would actually run on that device. You have these pre-created binaries. You just flash them on the flash or the SD card and get the device up and running. And with the Qt Creator integrations, you have the capabilities at your disposal to deploy the binaries to the device, debug it on the device. So what did we do about that? So over the period, we have improvised on the Meta Qt boot to Qt package, the Yocto package that we have. We have added some recipes. So now when you do the customization, and if you are referring to the Meta Qt 5 package that we make available, and that's what I've seen most of them do. So other than the other packages and recipes that you pick. So when you use this, you also get this feature at your disposal. So now your system integration team can create the QBSP images for your final device, final target that you would be working on. How is this done? So the Yocto integration is, so this specific integration is implemented in these two classes. What typically a system integrator would have to do is derive from this, and we have already documented the steps that one has to follow to change or export certain environment variables, and you would be taken care. So that's the link where you would find some additional information around that. With that, I'm at the end of my slide deck. Thanks for spending your time. If you have any questions, we would take them now.
Question that we had come in here is from if Qt has done the certification already, do I have to do any certification on my end?
Yes, the answer to that is yes, you will have to certify your own code. Qt Safe Renderer itself is certified, but your own code which interacts with that will need to be certified.
And what about speed performance, as it requires extra checks?
What's this? Is this speed performance for the Qt Safe Renderer, or if it's for the Safe Renderer, then it's fairly simple performance. It's fairly good performance. So there are some issues. If you change visibility on 5 or 6 elements, you'll see that there's a blinking effect because each safe event has to go to the Safe Renderer and be handled. But otherwise, it's good. But it's not a UI replacement. It's a UI. It's to help make the UI safer.
Why not make regular QML renderer safe in performance?
The reason for this is, as we said, I haven't counted the actual lines of code in the Qt Safe in the QML runtime itself, but there's a huge amount, and it depends entirely on Qt Core as well and various other components. So it's too much to do. Additionally, if you ever spend any time working on Qt Declarative or looking at the source code, you'll see that between releases, huge amounts of the source code can change, and each time it's changed, it needs to be recertified. So it's not practical or possible to do that with the Qt Safe Renderer itself. I don't know if there's a reason why we haven't stopped or frozen a branch and worked on that and rendered that. It's probably, again, because it's enormous. It's too much to do, and it's also not necessary. Yeah, it would be a huge rewrite, and it probably wouldn't add anything. It's meant to be safe code, which appears only when there's a crisis. It's not necessary to show it all the time.
When do I start integrating Qt Safe Renderer? Can I do it a couple months prior to the final release?
I think that's a tricky question. I mean, Qt Safe Renderer, it's best to start designing and developing it along with the regular non-safe rendered code. The real question is how long it takes to get it certified, and that's the key question here. You would probably want to give yourself in a good little bit of time to get it certified, to get it written and certified, and ensure that everything's there. So a few months before final release is cutting it a bit fine.
Will Qt Safe Renderer work with embedded Linux?
Yes, it will. But it's the issue is not whether it works with embedded Linux. Qt Safe Renderer will work with Windows desktop. The question is, can you get that operating system in the embedded Linux certified? Which, if it's Yocto, probably not. But if it's from a specialist Linux certified Linux vendor, then you should be good.
Let's say I'm making a new car in the USA. Do I have to use this Qt Safe stuff?
You do not have to use Qt Safe stuff. And this is as much a legal question as anything else. You need a way to ensure that some of your signals are visible in certain situations. So if the user interface crashes, then you would need to make sure that you have the important information constantly visible and certified to that level. You don't have to use the Qt Safe stuff. There are other safe renderers available. The thing about Qt Safe Renderer is it's designed to work with your Qt application at a very seamless kind of way. So yeah, there's other options, and check with your certifying authority.
Does the Qt Safe Renderer require some specific hardware?
Not any particular specific hardware. In the context of a certified product, you need to make sure that your hardware is also up to standard to be fail-safe and good to use. The Safe Renderer itself will run wherever Qt runs or wherever your application runs, but if you're producing a certified medical device and you use non-certifiable hardware, then it's not going to get certified. So yeah, it's more of a question on certification than where it runs, but Safe Renderer doesn't need any hardware specific to it.
What is the safe layer exactly?
So when we talk about the safe layer and the main layer, it's kind of a separation between applications. So the main application, which has your extraordinary, very cool QML, engaging QML effects, is running on a layer underneath. So if you're familiar with QNX systems, then you can set various pipelines and have one layer running in one space logically, and then you would, I'm just pressing the spacebar, so now hands-free. So you'd have the main application on one layer behind, and then you put the safe layer on top. So it's kind of the layered approach to UI. That way, if the safe layer, or if you had the main layer on top of the safe layer so that the main layer crashes and the safe layer is underneath it, if the main layer crashes and starts printing random nonsense to the screen, then you won't see the safe UI. Whereas if the safe UI is on top and the main layer crashes and starts writing nonsense, then you can still see the safe code. So it's kind of layered approach for application development.
Is JavaScript allowed on the Qt Safe Renderer QML code?
Very, very good question. No, it's not. And we talk about binding in QML and how fantastic Qt bindings are, but JavaScript does not run in the Safe Renderer. It's purely safe QML, QML elements, and purely the C++ backend to connect to that. You can't actually write the run JavaScript in there. So no JavaScript is allowed. Sorry about that.
Are the safe layers software or hardware layers?
Again, that varies. Mostly it's a software layer in the compositor. Because of course, if you're using, say, QNX and QNX is pre-certified and its compositor is pre-certified, then you can just do it in the software. If you were making a particular kind of design where you had a separate hardware layer on top of another hardware layer, I've not seen anything like that before, but yeah, it's done in software by the software compositor. Okay, I see another question saying, please show the links again to the GitHub repo for the GitHub repo for the Qt Safe Renderer. I have to stress that we're not actually sending the source code for the Qt Safe Renderer. That's a licensed product, and you will need to contact your the Qt company to ask about that. It's not publicly available for the source code. The source code is only for customers buying it. So the repo itself just contains a demo which is using the Safe Renderer. Yeah.
We have another question. Are there some limitations regarding the number of safe elements that can be rendered simultaneously?
Yes, there are. One of the limitations is not in terms of the number of elements that can be rendered, but the length of animations is limited to 1 second. So an animation longer than a second won't work. Rendering simultaneously, I think you can have as many as will fit on the screen. Honestly, I've not ever hit any kind of limit, and I've not seen any limits in the code. In fact, the Qt Safe Renderer 1.2 is a lot better at this because it has a better way of laying out the actual safe elements than the Qt Safe Renderer 1.1 did. Logically, there's none. However, it's very important that elements don't overlap. There's nothing in the Safe Renderer code which will stop you from overlapping elements, but it's not something you should really do because it will only paint one. You can't overlay two and it won't paint anymore. So screen space is probably the biggest preventative or limit for that, I think.
Okay, do we have any more questions from our live audience?
I'm going to say it's great to have so many people asking about the Safe Renderer. On the whole, people don't ask so much, but we're always happy to answer any other questions. We're very happy to discuss this in further depth.
Oh, looks like another question just came in. Is transparency supported by the Safe Renderer?
Actually, I did try that recently. So we have two things you can set color on. There's the text and the safe pictures, and you can set the color transparent on those. I haven't tried it on the safe text. I think it should work. I have tried it on the safe pictures, and the important thing to remember is transparency in terms of safe pictures is or the color is actually a reference to the overlay and not to the image itself. So a transparent color on a safe picture will just give you the uncolored picture, or which it's built around underneath. So you won't actually, we can't actually use transparency and animate transparency to make safe pictures transparent. You can set visibility to hidden, or visibility, or rather I should say opacity or visible false, opacity to 0, and that will hide elements. So if you have a row of telltales and you only want to show some of them, then just setting the visibility to 0 will do that. In fact, in the demo I was running, when we had some of the telltales showing and some of them not, what was happening in the background is the telltale was moving to another part of the screen and being set to transparent or visibility 0 or opacity 0, I think. So yeah, that does definitely work in that sense, but we can't do anything else with it particularly. And thank you very much.
All right, thank you to Becky and Shrikant, our experts from today's very informative session. We will be ending this session. Please note that you can contact us at info@qt.io or go onto our website at www.qt.io/contact-us and get in contact with us with any further questions that you may have. And we will be ending the session. Thank you all again for joining our session today.